Question 8. There's a part D as well. There it is. Got it summarized over the page. Okay, so let's have a look at this then. So P is equal to this. Calculate the number of these primroses P at the start. So A, T equals 0, P is equal to 800, e to the 0 is 1, so it's over 4, which equals 200 at the start. B, find T when P equals 250, so put 250 in then. E to the 0.1 T over 1 plus 3 e to the 0.1 T. So move this up there. On the other side, more than one term, put a bracket. So what have we got? We've got 750 e to the 0.1 T's here, plus a 250. I've decided to write them in reverse order for some reason. Move the 750 lots of that over there. 800 of them, take away 750 of them, it's just 50 of them. Okay, so that tells us then that e to the 0.1 T is equal to 5, 250 over 50. So that tells us that 0.1 T then. Move the e down and write the logarithm. And then T, that's over 10, so move it up 10 log 5. So T is equal to 10 log 5. A and B are integers, which is what we wanted. A is 10, B is 5. So that's part B. Part C, dp dt when T is 10. Okay, so P is equal to 800 e to the 0.1 T over 1 plus 3 e to the 0.1 T. So dp dt then, let's differentiate as a quotient, use the quotient rule, V, more than one term, put a bracket. V times du dx, 800 lots of e to the something differentiates to e to the something, multiplied by the something differentiated. Okay, that was V du minus u times to V, 0, and then the 0.1 will come down again. So it's 3 lots of e to the something goes to e to the something, multiplied by the something differentiated. So that's V du minus u to V over V squared. So what have we got then? We've got an 800 e to the t times 0.1 common. So that'd be 80 e to the 0.1 t there and there. That would be an 80. So cross that out and put 80. Cross that out and put 80. So that's that term taken care of. 1 plus 3 e to the 0.1 t here. Okay, 80. So that's this taken care of, but it's a minus 3 e to the 0.1 t, isn't it? Okay, good. All over 1 plus 3 e to the 0.1 t squared. These cancel. So you get 80 e to the 0.1 t over 1 plus 3 e to the 1 t squared. So there's dp dt. So find dp dt when t is 10. T equals 10. E to the 1, so it's 80e over 1 plus 3e, isn't it? Squared. 80 times e divided by bracket 1 plus 3 times e bracket squared. Oops, let's go back, it was squared, wasn't it? 2 delete equals 2.5946, which is 2.595 to 3 dp. So what was the question? dp dt p never equals 270. Okay. Well, it started off at 200. Right, it went to 250 when t was 10 log 5. Okay. Why does it never... okay. Right, dp dt. Okay, p is equal to that. dp dt is equal to that here. dp dt as t tends to infinity. This would dominate. It would be positive, but smaller and smaller and smaller. So it'll always be going up by less and less amounts. So presumably there's a maximum value. Because at infinity, this would be dp dt would be 0. So there's a value that it flattens out. The curve flattens out. The gradient flattens out as t increases. Okay. So the first thing we can say, or if we find what value is t here, dp dt is greater than 0, and dp dt tends to 0 as t tends to infinity. So looking at the graph, p is equal to 800 e to the 0.1 t over 1 plus 3 e to the 0.1 t, which is 800 over 3 plus e to the minus 0.1 t. This is always positive, so it's got to be less than 800 over 3. It's never going to get bigger than that. And 800 over 3, um, 266, which is less than 267, which is less than 270. So it never goes bigger than that.